Here are the differences between vals and defs. You declare a constant value using val, a method using def, and a variable using var. Most of the time you can use val over var. However, there will be times where performance is critical and you may choose to use mutable structures and variables. Let's see how a method differs from a function. Executing line 1 shows you what the compiler sees when you use the word def. Method multiply, that takes two parameters and returns an int. When executing line 2, the compiler doesn't see a method but a function that takes two ints and returns one int. Feel free to open IDEA IntelliJ, create a new Scala worksheet and type this code in. In Scala, there is a difference between methods and functions. Functions are in fact classes or objects with an apply method. Sometimes the compiler turns these methods into functions for you to make your life easy. Other times, you want to explicitly transform a method into a function, so you use Eta Expansion to lift methods into functions. On line 1, we define method m. On line 2, an instance of a function assigned to f. And on line 3, we transform method m into a function using underscore. You can see that the result from line 2 is the same as the result from line 3, a function from int to int. This shows you that you can use underscore for Eta Expansion to transform a method into a function. Now we know functions are in fact objects or classes extending various function traits. The n in the function trait stands for the number of parameters your function should have. Function 2 has 2 input parameters. Function 5 has 5 input parameters, and so on. There is a maximum number of parameters, so don't go making functions with 1,000,000 parameters. Here, function 2 takes 3 type parameters. The first 2 are the input types, and the last one is the type of the output. The function body is in the apply method, as you can see here, and this function takes 2 ints and multiplies them, returning the result. Currying is the technique of transforming a function with multiple arguments into several functions with just one argument each. This is derived from lambda calculus. The way multi-argument functions are handled is by chaining return functions, and we're going to look at an example on the next slide. If you want to curry a function, you wrap each parameter and its type with parentheses, as you can see here on line 1. In this example, parameter m is wrapped, then parameter n is wrapped. A curried function means you don't have to pass both arguments at once. You can pass one argument in one method, then pass the function to another method which fills the other argument. Just for fun, on line 2 we turn it into a curried function using underscore, which we learned in Eta Expansion. On line 5, we pass parameter 2 to the curried method, and we use Eta Expansion on the resulting function. We assigned the resulting function to constant times 2. The type of this function is from int to int. Finally, on line 7, we pass the other parameter into the function, and the function executes, giving us 6. Another way you can execute a function is if you know both parameters at once, and this is shown on line 8. You pass both 2 and 3, and the result is going to be 6.